We're all familiar with the need to reduce carbon emissions to combat climate change. In the UK, around 40% of emissions come from buildings. In an effort to reduce carbon emissions, changes have been made to make all new buildings more energy efficient. These changes are leading to buildings that are very different. They are better insulated and more airtight, but there is evidence that overheating and poor air quality are becoming more common. It is therefore important to ensure that people using these buildings understand how to minimise these problems. English Martyrs School is one of 22 schools in Leicester which have been rebuilt or refurbished as part of Leicester's Building Schools for the Future programme. This video shows the projects undertaken by the Eco Martyrs to gain a better understanding of their new school buildings and how to manage their indoor environment.
We're the Eco Martyrs!
Firstly, we learnt about heat transfer, conduction of heat. We had a metal pole heated at one end, and as the heat travelled along the pole, the pins in the pole dropped out of it, demonstrating heat travelling. Convection was next, which is about heat travelling around the room through the air. Next, we were told about long-wave infrared radiation, which means heat travels to a cooler place from a hotter place. Finally, we learnt about ventilation, which was split into two parts, mechanical and natural. Natural is escaping and coming in through a window. Mechanical is things such as extractor fans and trickle vents. This project is concerned with investigating the sustainability of our new school building and comparing it to the old school building. Dr. Paul Cropper and his colleagues from De Montfort University worked closely with us over several weeks. They have taught us about how important conduction of a building are to make sure we are comfortable and can learn in a healthy environment, and also how important it is to manage buildings' environments to make sure it's comfortable to learn in.
Our first prediction was that the new buildings would be better ventilated, therefore would have a lower CO2 level. We also thought that it would have a more comfortable lux level between 300 and 500 lux. We thought the new buildings would be more comfortable, therefore students would feel happier in the new buildings than the old buildings. We also predicted that there would be a more comfortable temperature, therefore they'll be more comfortable in the new building.
We met with Dr. Paul Cropper, Linda Toledo and Amrita Dasgupta, who taught us how to use the lux meter, CO2 monitor, temperature data loggers and the thermal imaging camera. We looked at our plan of the school and devised a systematic sampling strategy to decide how we were going to monitor the thermal and ventilation of the school. Then we went around the school, placing the data loggers and taking measurements and recorded them on a data collection sheet. We carried out the same sampling strategy at different times of the day. We also took photographs of the building controls used to manage the ventilation and thermal performance of the buildings. Finally, we completed a user survey to find out staff and students' opinions of the thermal and ventilation qualities in their classrooms. We collated this data in a spreadsheet ready to analyse with Dr. Paul Cropper, Linda and Amrita.
Once we collected the data, we found some interesting results, particularly in the carbon dioxide reading. For example, the sixth form block was nearly 4,000 parts per million. Towards the end of the lesson, it was higher than at the start. In classes in the St Mary's building, carbon dioxide reading went up rapidly. With a class full of students, it went from 898 parts per million to 2104 parts per million. We also found very high readings in the French classrooms, which are in the old building. The results show that the heat control in the new building is better than in the old building, and the majority of students think the new building is more comfortable in space and heat.
Back in the classroom, we sorted out the photographs into old building and the new building. We then classified them into sensor, control and function. We placed these on the whiteboard relating them to thermal, ventilation and lighting lighting characteristics of a building. From this, we found there are more ways to manage the new building than the old building. This probably explains why people are more comfortable in the new building, and also highlights the importance of actively controlling the new building.
We have learned that the old building has high levels of CO2, meaning that the ventilation is poor. However, one of the new buildings, St Thomas Aquinas, also has very poor ventilation, suggesting that the way in which the controls are used are inconsistent between the new buildings, because CO2 levels in St Mary's are much lower than the old building. We have also learnt that the temperature in the new building was more stable than the temperature in the old building. The old building has lows of 14.2 degrees and highs of 21.7 degrees, whereas St Mary's has a much smaller range with a low of 16 degrees and a high of 22.8 degrees. Students do feel happier in the new building, mainly because it's a more comfortable building. This proves our first hypothesis, and that the new building is more comfortable than the old building.
Some of the strengths we had throughout this investigation was we all worked well as a team. With the results we collected, we came up with benefit conclusions. We all enjoyed ourselves. We got some good equipment to measure out lights, carbon dioxide and other stuff. We had some help from Dr. Paul Cropper and some other visitors, which helped us out a lot. And we learned a lot about data presenting and analysis methods. But we also did have some trouble, like with timing, as we didn't have a lot of time. Sometimes we did struggle with data handling, and we weren't always be able to get the rooms we wanted to monitor.